Hello, students. Mr. Odom. I'm back after a week of kind of putting the brakes on a little bit here. I wanted to go back and just kind of probably something I should have done earlier in the year, going over root words. And it's one of those things where you don't think very much of it until you get into a botany class or zoology class or chemistry, a scientific class. If you want to go into nursing or the medical field or veterinary medicine, these root words are going to come in handy. Okay, being able to decipher long medical terms based on their, whether their base word or their suffix or their prefix, it's going to be important. And I know there are college classes that are just on medical terminology. You'll spend an entire semester just going over the basics of how words are put together and what does endo mean versus ecto, and what does amino mean versus uh, a butyl group for organic chemistry. Because if you're a nurse and you don't understand the difference between a butyl type of medicine and an amino medicine, that's a big deal. That could be life or death. So that stuff's kind of important. So we're going to switch gears here and kind of get back onto the parade of animals. And we left off with the worms. So we started off with viruses. We graduated to bacteria. We moved on to the sponges. Sponges are the first animal of the animal kingdom that have the very, very basics of what an animal is: multicellular, eukaryotic, heterotrophic, some type of mobility. And those are the four characteristics. And that's all really a sponge has. It doesn't have any specialization. It doesn't have any cephalization. In other words, it doesn't have a head part. It doesn't have centralization or the beginnings of a brain and spinal cord. And once we move from the sponges to the cnidarians, and then from the cnidarians to the worms, what we start seeing is we start seeing this idea of cells becoming more specialized. We start to see the rise of nervous system and digestive system and hepatic systems and cardiovascular systems. We see cells being more specialized in doing very specific functions. That's a product of evolution. We start seeing the development of centralization. The nerve net that a jellyfish has is kind of the first thing that we see for this. But by the time we get to the annelids, the segmented worms or the earthworms that you go fishing with, there is a distinct head and a very distinct tail to that animal. And in the head portion of that animal, you're going to have some sort of brain, and then along the back of that animal is a notochord. Those are that is the kind of combination of cephalization, the head part, and then when you take that set of ganglia, which forms the brain of an earthworm, with the notochord that serves pretty much the spinal cord, now you've got centralization, and you start to see the rise of all of these different types of body systems. And we're going to see it again with phylum Mollusca, and that's where we're at now. That the mollusks, the clams, the snails, the octopus, the squids, all those different types of aquatic animals for the most part. So what you're going to see with phylum Mollusca, number one, a lot of soft bodies. You can take an octopus that doesn't have a single bone in its body, and if you put it into a specific shape, it will take the shape of that object, whether it's a jar, a pipe, the belly of a boat, whatever. Because of that soft body, it's going to take the shape. All mollusks have some sort of foot, some sort of mantle. Some of them have some sort of shell and some sort of visceral mass. And we'll talk about each one of those concepts here as we go through there. Okay, so very, very unique. Think of an octopus and the soft body of an octopus. All of the mollusks are going to have that kind of body plan. So there's three classes of mollusks. Okay, the first one is called the gastropods, which have one shell or even no shell. So think of snail or a slug. Okay, those types of creatures there are your gastropods. And again, think of, look at this: gastro meaning stomach, essentially; pod meaning foot. Okay, so essentially with a snail, you have a foot covered by a shell. With a slug, you have a foot. It's essentially a big giant muscle that crawls along the ground. Class bivalva, the bivalves, the two valves. Two shells, clams, oysters, scallops. If you ever go swimming at Lake Tahoe, every now and then you'll step on a type of clam. You can pry it open. You're not going to find a pearl at the bottom of Lake Tahoe, but in the ocean, because of all the sedimentation and all the salt and things, you will get some of those guys that are hiding a pearl. And then the cephalopods have an internal shell, octopus, squid, and you're not going to find a lot of shells here with the cephalopods. Again, look at the name. Cephala is head, pod is foot. An octopus is nothing more than a head body, okay, and 8 legs, 8 feet. That's all it is. Okay, a squid has a head body and several tentacles. All right. So again, head, foot, head, foot, head, foot. 2 valves, stomach, foot. Okay, those are the types of animals that we're dealing with here. So what is the foot? Okay, the foot is the soft muscular structure used for movement. When you think of how a snail moves, it crawls along the ground and leaves that little slimy trail behind it. But it's the peristaltic movement of that muscle as it rolls over the ground and causes this thing to move. The mantle then is a thin tissue that surrounds the body and secretes the calcium carbonate shell. So the foot is used for movement, and then on top of that foot is a layer that's going to kind of be the go-between between the foot and the shell. And the mantle is what's going to cause that shell to be formed. The radula is the flexible tongue used for feeding. Okay, this is basically the mouth. Hopefully my screen doesn't go crazy here. This is the mouth that causes the plant to feed itself. Whew. And then the visceral mass is the body area. Okay, so again, this is going to be a pain in the butt. So this is your foot. Okay, this is the movement portion. You've got the mantle, and you've got the rest of this is going to be some sort of visceral mass. Okay, the radula of the snail. This is the mouth of a snail. You don't ever see it, but as that snail crawls along the ground here, it's actually kind of gnawing and grinding away at whatever it's crawling on. Okay, and these are just full of teeth. You'll never feel it because you're never going to get bit by a snail. But these are very, very gnarly type of teeth. An octopus, a squid, they're going to have the same type of structure here. That's why they're very, very, very deadly. Okay, so think about the snail here as it comes upon its food. Behaves just like a mouth. Okay, so the mouth opens up. The radula kind of extends out, picks up the food, and drags it back in. Okay, it's very, very similar to what we have. The shell, called the valves, could have 3 layers. It's going to have an inner layer on the shell that's very smooth. So if you ever opened up a clam at Lake Tahoe, you know that the underneath, the inside part of that shell is very smooth, used for protection. The middle part is the calcium carbonate. That's the strong part, and they're very difficult to break apart. And then the outer part is kind of rough. It's not a very pretty sight. Usually it takes on the color and the chemicals that surround it. So you've got the inner part that's very smooth and very soft. It's going to protect the inner body of that organism. You've got the hard shell itself, and then the outer part of the shell that's going to kind of be the go-between between the environment and the calcium carbonate. All right, so inner layer, very soft, and you'll see a lot of unique colors when this thing is put together. Very beautiful colors, very ornate patterns. Then you've got the shell itself, and then the outer part of the shell. Okay, so very unique structure here with the shell of a bivalve, or just of one of these creatures in general. The feeding, a lot of these guys are going to be, they've got lots of various ways to feed themselves. Some are carnivores, like the Humboldt squid is in the Pacific Ocean is a very ferocious carnivore. Some of these guys are herbivores. A snail is going to just basically devour whatever it can get its radula on. Some of these guys are filter feeders, like clams. Okay, they're going to siphon water in, filter out the minerals of the water, and then siphon the water back out. Some of these guys are excellent decomposers and scavengers. Some of these guys are parasites. Okay, so